Hello guys, so in last video we talked about like how we gonna like find MZ byte in a binary. So we read some bytes while putting on a buffer, and we read like first two bytes and at the index of the buffer, and if it's showing that it's M and Z, then it's an executable file. If not, then the file is not executable. So today what we're gonna do, we will gonna read about like optional header, PE header, like DOS header, and we will gonna find like what kind of things it has, and we will gonna print it on our debugger. I know the things is going slow, but I think this is the best pace I can like run this course, because if I like jump too fast, like put 1 hour 3 hour videos, it will be like hard for me to continue and you will get bored. So it will will make video slow and slow, and so you can grab things and experiment things by yourself also. So to start this journey, last time we read the DOS header. In DOS header, we have like 4D and 5A, which saying like MZ. We read it last time. So if I go to the original like official documentation by the Microsoft, and last time we read the magic bytes, but today we will gonna need this, and it has the offset to anti-header. So this is the flow we're gonna go today. So we are on DOS header because we read the MZ bytes, and now we're gonna shift to image anti header 64. So we will come to our code and we have to add some header this time. Last time we were just working around like anti ddk.h. Now if we have to do some more digging, then we have to add some more header. Include, it will be like anti-ifs.h, and another one is include anti-image.h. So we will gonna go here. I will gonna change some things. I will first of all I gonna remove this to make our code look good and make so that it can run faster. And I will gonna change this, and if I change this and this and this. So what it's doing that before like checking everything, it will check the first thing. If it's like not correct, then it will not check everything. Last time we were checking everything, so it's like make more sense rather than what we say. I have to add uh, the curly braces here, and we're gonna return false, and we're gonna say anti-header not found, and this is not a binary. So we already have a buffer and we already have a structure, image DOS structure. So what we gonna do, we gonna point to this structure and call it a DOS, and we gonna save it to uh, align it to our buffer. So everything we will gonna save, like the buffer contains a raw data in hexadecimal, or like you can say like raw data for like OS, which can understand. For like us to understand, it should be structurized. So the buffer is passed into our header, and sorry, in our the structure of the DOS header, so we can read all of these things. All we care about like this thing, it has offset to like anti-header. If I go here and I do this, well, before going anti-header, I want to tell you something about anti-header. Anti-header is a structure and it contains three fields: signature, and signature contains PE. This is the signature for every executable should have. We're gonna check this also, and it contains a file header and optional header. This is also important because, or don't go by the name like optional. It's not optional, it's very important. So if we go like file header, it contains, it's also structured, it contains bunch of things like machine, number of section, time, date stamp. So it contains like machine contains like for which OS is actually the binary is made for, like AMD 64, ARM 32, so on. A number of section, like if we go to the picture again, there is a section table, and we're gonna find that there is text, data, data, resources. So generally, the executable code should be in text. So that's we're gonna check in our next video, not this video. And in optional in optional data there's like bunch of data. I want you to read everything, and I want you to study like how malware manipulate all these fields to like bypass the EDR or antivirus. So in this today we will gonna focus on like address of entry point, and another is subsystem. Address of entry point is like from which section is loaded into the memory and is being executed. Is it coming from like text, our data or resources? If it's coming from text, then it's a like genuine binary. If it's coming from any other section table, then so a section, that it means it can be a malicious activity. It's like encrypted shell code or stub, anything you can call it. So there are the four things we have to check. So where were we? We have the DOS header. We have to move to anti-header. So we will gonna use what we say anti-header here. Now we're gonna remove some unwanted symbols, and we will gonna call it anti, and we're gonna do the same thing again. Just copy this and let's paste here. And so buffer is our whole data we have, and this thing contains the offset. So in buffer, if we in buffer, if I say if in buffer I add the offset, so that means I will get the anti-header. That's what it means. So if I add where were we? So in DOS on buffer, if we add offset of anti-header, which is this, we will reach to anti-header. So right now we reach, let's assume that we reach at anti-header. So to check this, that if we are at like anti-header, we will gonna check the signature. So what we're gonna do, we're gonna do like anti points to the signature. Where is the signature? Is it? So it should point at if it's not equal to image empty signature, then it should return false. So log what we say, an invalid empty header, and it should return false. Return false. That's it. So if like things doesn't match by our condition, then it will stop everything and return false. So if we assume we already in anti-header, so we can jump to file header and optional header. So if we go to like file header, we're gonna use only two things here, like machine and number of section. So where we can save this data. In order to save this data, we have to make a new structure for ourselves. So what we're gonna do, we're gonna create a new structure. Let's create a new structure, type a def and a structure defining stur. Wait, okay, I have problem with name or spellings. So wait, let me check from here. Okay, let's start spelling. Sorry, I have problem with spellings. Okay, that's why I copy paste. So we're gonna call it an PE info, and we have to define the field. So we're gonna use machine here, and let's check the data type. It has its word, but in kernel coding we can't use it. So in term of where the word data type used, we have to use use short. So we will gonna define the data type here, use short, and that's the machine is done. And another thing, number of section. You can name anything you want, but I am just copy and paste because it's easy. And we have to define like PE info, and pointer should be PE info, and we are done. And we have to also pass this in our function so that it's giving the output. So we have to write out here, and it should point out to our structure. So if we using a pointer info, and we will gonna call it PE info for simplicity. So we created our structure, we passed in our function, so we can now save it in our structure. So we just assuming that everything we are writing goes as we planned. So we already in anti header, so we can save the data. So what we say, PE info should point out at what we say machine, right? As we wrote, so it should point at machine, and it should be saving anti structure should be pointing it at file header, and the field name should be machine, right? And next thing we were doing the number of section. Let's copy paste here, and it's the same thing we're gonna do, points out to the file header and the field. So we already done with what we say image file header. Let's move to the optional header. So like I told you, I'm using only four like fields. You can use as much as you want, study it, learn it, what everything it do, experiment it. But later on we're gonna do like whole series of the like bypassing the level 1 EDR that we make, and those video won't be on YouTube because some of the YouTube policies. So let's see how we're gonna I can share the videos with you. So first thing, we have to use address attribute. So we have to write in our structure. So what is the data type? Data type is dword. For dword we will gonna use ulong. So we use here ulong, and let's close it. And another one we will gonna use a subsystem is word. So we're gonna use subsystem. It's like u short only because it's for d word short, and we are done here, and we can save these things here. So p e info, why I'm making so much mistakes, info same goes here, info, and what was the name, subsystem we already copied it, so we don't have to, and should point at what we say, what was the name, optional header. So we're gonna save it to the optional header. The field is subsystem, and we are done here. The another one is p info. Uh, what was the address point? Address entry point. It's very important because we're gonna use it next time. It's very important. In our next video, we will focusing on like address of entry point only, and we're going to use NP optional. Let's copy this also, and let's copy this also, and we are done. And what we're going to do, we're going to log them out, and we will going to just copy paste again, and we're going to write, and I want it in hexadecimal, so I want it in what we say x, and let's pass the what we say, we already save it here. So, and again we have to, it's like boring task to write everything again, just bear with me. So for like a decimal, then you can use U. That's I'm just showing you the differences. And let's copy this again and paste again, and then again log, and this time subsystem, and percent is U, and uh, let's pass the subsystem. And the last one we have like PE entry point. So let's type entry point here, use hexadecimal. We're gonna pass this. And our function is a boolean, so we have to return okay, I am. So we have to return true because our function is ending, return true, and we are done. We are done our like new function we made alpha. Here we are passing what we say our structure that we created here, and we saved all the like main fields of the what we say file executable file in our like structure, and we printed on our debug view. We also have to create a structure over here like what is this pe info, right? Pe info, and we're gonna write pe info because I'm lazy, and that's it. We defined our structure and we're gonna pass it here, and we're gonna point out to our structure pe info. Let's correct this. So that's done. Let's see how many bugs we get. Okay, I tested it. I didn't test it last the video. The audio was sucks, so I had to create another video. So I have to stop it. Stop now and stop. So let's say delete, and that's it. And we're gonna see here, and we're gonna paste. No, nothing red. That's a good thing. So we're trying to compile it. Build, compile, and it's done. So let's try to create everything from start. Yes, success. And we already have a debugger view. And I see start norm, and it's done. So if I close it, it won't show anything. But if I open a notepad, so here is a notepad. In notepad, you can see the machine 8664. So if I go in machine, where is the machine? In file header. So if I go PE format, you can see 8664 is for like AMD64. So there are every machines you can have. And where we gonna use machine, because when we gonna use magic, we can compare it with it, like with the binaries telling us that it should be like x64 like AMD 64, but it's saying magic is saying is 32. So there is like malware developer want to make us like believe that, and we're gonna break our like EDR or antivirus. So that's how we're gonna make some rules. So in next video, we're gonna make some rules first so that I can show you how we can stop a binary from running it. And after that, in single window, and we're gonna check in from which section what we say the execution actually starts. Where is the entry point in like entry point of the code in located in which section. So that's it for that's it for today. And if you like the video, I humbly request you please like and comment. Please, I need a feedback from your side also. And please share. The more the likes, the more the views I will get, the more the motivation I will have to make such these videos. So thank you guys for watching this video.